Okay, so a couple quick issues. Now, when you're asked to factor something, you're asked to factor it completely, right? There were a couple examples and I'm looking specifically at the factoring harder quadratic expressions one. I had a couple problems that weren't behaving properly. I want to show you something. Like, for example, on the first couple on that assignment, it let you answer like that and it gave you credit, and it shouldn't have. So I need to fix those. So by the time the test rolls around, that will not be correct. What's wrong with that? Good, okay, because if you look at those factors, the second factor here, the 3x plus 3, is not completely factored. There is a greatest common factor there. I could extract a 3 from that, from both terms in that factor, couldn't I? Right? So what this really should read is, yeah, it should be 3x plus 1 times x plus 1, or you could write it as 3 times the quantity x plus 1 squared, either way. Okay, make sense? Okay, good, all right. Okay, but most of them, like that was only for the first couple that it let you do that. Then after that, with the harder ones, it made you answer them correctly. For example, this one you had to answer correctly, and people were having a little issue with that. Yes, sir?
Where on the fact sheets when I gave options? Fractions doesn't pop up, or?
On these?
Yeah.
No. I mean, it would, okay, yes and no. Now, when you're finding zeros, yeah, they might. When you set the factors equal to 0 and solve, you're going to get fractions. But when you're factoring, you won't. You won't get, that's because when we say, is it factorable, what we really mean is it easily and conveniently factorable? Does that make sense? I mean, a lot of times you theoretically, well, if you really worked at it, you could factor just about every quadratic function or expression that has a solution, right? If the quadratic function has zeros, then you could, if you worked hard enough at it, factor it. But we don't want it. I'm going to give you a much easier, better technique later. So factoring is only going to be useful to us when it's easy to do. Okay? So we're going a little bit overkill right now, I admit, because you're not always even going to mess with trying to factor things unless it's pretty easy to do. But factoring is an important enough skill that I'm kind of making you do a little more than you really need to right now, because later on it'll come in handy.
What is it used for?
Well, like for example, when we get to calculus, for example, it's a skill that enables you to do some other things later more easily. Let's just for now, just kind of trust me on that one. It is an important skill to be able to kind of break things apart in your mind like that. So what about this guy? Now, I'll make this quick. There's a tendency, what I saw a lot, I had excellent questions yesterday. I really enjoyed yesterday, it was good. People made a lot of progress. One of the things I saw is people had a tendency with something like this to say, aha, okay, A is 8. So I got to use the A times C then split B. And they jumped right into that mode. Now, I'm not going to do it that way because there's a lot of work that way. But look what that entails. A times C is big, right? A times C is what, 1280? So if you want to find numbers did I do that right? Is that right? Let's assume I did. If we want to find numbers that multiply to 1280 and add to 72, first of all, that's kind of hard to do. I guarantee you could find them. It'll work. But it'd be kind of hard to do. And then you still have the whole rest of that process to wade through, right? That's a big deal. And when you're all done, what you're going to end up with are some factors that aren't completely factored. Okay, you're going to get something kind of like that when you're done, right? Okay, what's a much better way to handle this one? Yes. Okay, you always want to start, and this is why. Look how easy this problem is if you don't forget the first step, which is always to try to factor out a greatest common factor. 8 goes into everything there, right? So I could rewrite this. If I pull an 8 out, look what I'm left with. X squared plus 9x plus 20. That's easy, right? That's the easy kind. A is 1. Can you find two magic numbers that multiply to 20 and add to 9? 5 and 4, we're done. That's it. You see the point, how much easier that is? Right, so you always, always, always want to try to do that. Try to factor out a greatest common factor whenever possible. Okay, last issue was these. I want to just take a quick look. Okay, now these are definitely A times C then split B problems, right? I mean, they look like it. Unless there's an easy alternative by just trial and error. This one right here, I'd say, I don't know. I mean, that one maybe isn't worth the trial and error. It sort of looks like it might be because A is 7 and B is 10. And 7 only has one factor, or I mean 2 factors, right? 7 and 1. And 10 only has a couple of different possibilities, 10 and 1 and 5 and 2. But here's the problem with that. Here's the problem. I want you to see this. So if I try to just split this one apart and do trial and error.
10 and 1 though.
Say it again.
You would want to do 10 and 1 though, because 10 would just be 70, and then it would actually come out really nice.
Right, 10, and so you can kind of see that one is going to work, can't you? I mean, that one, but the problem with this, if I try to do this, and the A times C then split B would be really easy with this one too. Look at all the different possible factors of negative 10 we've got. We get negative 10, positive 1, negative 5, positive 2. But I could also do positive 5, negative 2, positive 1, negative 10. I have quite a few to try, don't I?
You just redid positive 1 and negative 2.
I did?
Yeah.
No, because the positive 1 could be over here. See, I can flip all those around also. Because this one is going with a 7 and this one's going with a coefficient of 1. So they're going to give me different results. So, I mean, this one's probably still worth doing that way. I mean, because you are going to be able to find these pretty easily, aren't you? But it's sort of, whenever you have the negative sign there, you know that you're going to have to try both possibilities. When you're multiplying a positive times a negative, you know that you got to flip those around, right? Now, look how much easier it is on this one on the left. On this one on the left, if I break this one apart, I know I've just got a 7x and an x, and the only possible combinations of 2 are 1 and 2, right? There's only 2 things to try, right? I can just try plus 2, plus 1, plus 1, plus 2. That's it. See the difference? Now, if this had been a negative 2, then I would have had more combinations, right? Then I would have had a negative 2 times a positive 1, a negative 1 times a positive 2, and I also would have had positive 2, negative 1, positive 1, negative 2. See the difference?
Wouldn't there still be?
Did we miss something over
Yeah, we
here?
missed a lot over here.
I think we did miss a lot over
You
here.
what I'm trying to say is you missed some on the positive 2, because you have negative 1.
No, you can't. Oh, I'm sorry. You know what? I did that wrong. These all would have been negative. Gosh, I screwed that one up. There, let me do this one again. I mean, it's the same idea, but I don't want to confuse people. So real quick, I'm sorry I messed up. Let's look real quick again. So they're both going to be negative, aren't they? Right? They can't both be positive because they have to multiply to a positive and add to a negative. So my choices are only negative 2, negative 1, negative 1, negative 2. That's it. 2 possibilities. Do it that way for sure, right? Over here, I think we did miss a couple. We had negative 10, positive 1.
Could be 8, right?
We could have also had, it should be 8, yeah.
Because it should be, and then there's negative 1 on that side, and 10 over there. And then
Yeah,
10 over
that's the
there.
one we missed. Yeah, we got negative 1, positive 10, exactly. And
And then you
then,
have the 2's on the left side and 5's on the other side.
right, so we could have, there you go, cool. Yeah, we could have done. So there's a lot of them, right? 2, negative 5, negative 2, positive 5. I think there's one more I missed. I only got the 10 over here once. It could have also had a positive 10. See, look at all those possibilities. See what I'm saying? that's, I mean, it's probably easy enough on this because they come together pretty easily. Maybe this time you can finesse your way through it just by thinking about it a little bit. But what if that wasn't so simple? What if that wasn't a 69 there, so you knew it was a 70 and a 1, you know? Then it gets just a little bit tougher to do. And I think it's, you know, at some point, you just want to do the A times C then split B stuff. Does that make sense? I mean, you kind of see the thought process that I'm trying to make you aware of. It's, you got to kind of weigh whether it's worth it or not. If that's a plus sign, and these are both prime, that's a slam dunk. Then for sure, you want to just trial and error, because it's so quick. There's only 2 possibilities. It's way quicker. Questions on that? Okay. All right. Any other questions? Raise your hand, how many people want to see an A times C split B? Raise your hand if you want to see one of those. Because if it's just a few people, I'll just pull you up in the lab and we'll do it in there. So just a few people? Okay, that's fine. I'll just have you guys come up and we'll go through in there. All right, I think